In this video, we'll generate the Taylor-Maclaurin series sum expansion of exponential decay and exponential growth using double factorial and factorial. Begin with the decay, which is equal to R formula, exponent of the x values from negative 2 to positive 2. And since this is decay, so it is negative 1 times the x and the growth. This is our formula, exponent of the x values. And since this is growth, this will be positive 1 times x. And we'll chart this. Insert chart. And we'll use scatter chart. Use row 1 as header, column is label, and the series. The point size will be maximum. The trend line will be exponential. The label, we use the equation, the legend, position at the left. Here's our trend line. And the trend line equation, which is exponential. Next, we generate the Taylor-Maclaurin series sum for both the growth and decay, which is the summation of a times x to the power n. A, the expansion coefficient, can be factorial. It can also be double factorial. And the value of n is from 0 to infinity. In this case, we can go as far as 10. 10 is good enough. And the value of k is negative 1 if it is decay, positive 1 it is growth. So data validation, if it is decay, negative 1. If it is growth, positive 1. Inside. We'll start with the decay. Then we continue with the coefficient. We start with the factorial. So R formula of k raised to the power n all over factorial n. Enter. And the double factorial, which is R formula k raised to the power n divided by, now there are two parts, double factorial n and double factorial n minus 1. So let's start with double factorial n. Double of n. That's the first part. Now the second part. Again, factorial double. This time it is n minus 1. N minus 1. Then enter. You'll notice these values are exactly the same. They are exactly the same except for the first item. We'll correct this. So if n is 0, then 1. So we use if n equals 0. If n equals 0, then 1. Otherwise, calculate. Now it's corrected. They're both the same. We can now calculate the Taylor-Maclaurin series sum. This is our formula, series sum of the x values raised to the power n, where n starts from 0, incremented by 1. And the coefficient, you can choose any of the two. So we'll choose the double factorial. So the red and the blue are the same, but there's no equation. So we correct the chart, edit chart, and you correct the color of the growth to green, change it to green, and the point size will be maximum, trend line, and exponential. The label, use the equation. In case of the expansion, the point size will be none, but the line will be maximum. So it's a trend line. That is, if k equals -1, meaning decay, the expansion approximates the decay. If k equals 1, the red is on the green, so the expansion approximates the growth. We calculate this regression coefficient using the LOGEST function. So LOGEST data y and data x. The value of b1 will be ln. So ln of these values, -1. So this matches to this. Well, this is b0 matches to this 1, while b1 is -1. Next, continue with the expansion. So logest data y and data x. So right now our value b0, 1, and this will be ln. So this is equal to ln of this value. So it's +1. So it's +1 right now. And the value the growth, which is logest data y and data x. And this will be ln of this value. So it is +1. So it is +1. That's for the growth. We toggle this to -1. This time, these values are the same. The expansion approximates the decay, and their trend lines are the same. Trend line equations are the same. We toggle this to +1. The expansion approximates the growth. Their coefficients are the same. Their equations, trend line equations are the same, and their trend lines are the same. This completes the use of double factorial and factorial to generate the Taylor-Maclaurin series sum of expansion in growth and decay, and its largest exponential regression.